All right, good morning. I will say today I am tired and grumpy, and I sort of hate technology, and I kind of wish I were just back in school teaching you this. So, I also have a visitor. Would you like to say good morning, Mr. Visitor?
Good morning.
All right, so this video is going to be parallel slope. Well, really, it's going to be parallel lines and then how their slopes relate. So the idea for this is going to take us to when we're talking about things like squares in the coordinate plane or rectangles or parallelograms, and if you're trying to find whether the two lines never intersect. So parallel lines are two or more lines that never intersect. And the reason that they never intersect is because they have identical slopes. All right, so what that means is, for example, if I were to draw a coordinate plane, and I'm just going to start really, really simple with a line that goes horizontal. Okay, so say I've got this line here, we'll call that line L, and then I've got this line here, we'll call this line M. You could tell that these lines are parallel because you have brains, and you understand that parallel is like railroad tracks where they never intersect. Now, the reason, though, that that happens is because if I were to describe the slope of the line, slope is described as rise over run. And we'll talk about the actual math of it, but let's just talk rise over run. So say I'm starting here, and I'm going to go to this point on the line. I'm not rising at all, right? I'm not going up or down, so my rise for line L would be 0, and my run to get to the next point would be 1. Well, 0 divided by 1 is just 0, so this has a slope of 0, because you're running, right? But you're not rising at all. So there's movement, but it's not movement that is rising. Thanks, Daniel. Sorry, I do have a student. Yay! All right. This one, same idea. If I put a point here and then a point next to it in the next kind of spot, next countable spot, I would have the same idea. Slope we represent with the letter M because it's modus of slope is what they used to call it. So my rise again is nothing. I'm not going up or down. And I'm running forward. Now, say I said, well, but Miss City, what if I wanted to run more than 1? Sure, go ahead, right? I ran 2. Well, what 0 divided by 2? It's still 0. So what happens is they have that same slope, which keeps them parallel. Oh. This is true if they're perpendicular. Not perpendicular, sorry, my brain is melted. If they're vertical, vertical lines actually have what's called an undefined slope because you are rising without running. And when you rise without run, you get some number divided by 0, and you can't divide by 0. So you know something is parallel if it has the same slope of 0 if it's horizontal, where it has the undefined if it's vertical, or say we were talking about, I don't know where any of my erasers went. Luckily I have this towel here. Or if we were talking about lines that had slopes that were not 0 or undefined, we could count it on a coordinate plane, which is super helpful. And that's the way that I recommend you do it. So when I give you the assignment for the week, it's going to have mostly counting. You can do the slope formula, but you know, at this point, if you don't remember how to do the slope formula and we're not in class together for me to like reteach it to you, it can be kind of complicated. But so let me do a couple parallel lines. So there's one line.
More than one line?
It's always more than one line, Daniel. Now, these two definitely look parallel, and the way that we tell for sure is we count our slope. So, for the slope of this one, we're going to rise 1, and then we're going to run 1. So I have a slope of 1. All right. Now, the only way then they would intersect is if they both had the same slope as if they started at the same spot. But check it out. This one also, how much does it rise, Daniel?
1.
And how much does it run?
2.
Whoop, tricked you.
1.
1. It rises 1 and runs 1. Therefore, the slopes are the same. Therefore, the lines are parallel. So when you're working on this week's assignment, what you're going to be looking at is you're going to be looking at solid shapes, right? So I'm going to give you a solid, a solid shape. And we'll start really simple, like with a
solid shape.
I'll show you. All right. Sorry, apparently I'm teaching this to my child as I'm teaching this to you guys. All right, so let's start with something really, really simple, like we want to determine if it's a square, right? So, what do you know about a square?
They've got...
How many sides? Do you remember? 1, 2, 3,
4.
4. Okay. What do you know about the sides of a square? How do they compare to each other in measure?
They are all the same.
They are all the same length, right? So we have 4 equal sides. And then the other thing that makes it a square is that we have 4 90-degree angles. And we'll prove that using perpendicular, which I'll show you in the next video. But the idea here is I could at least figure out the length of the sides, and I can figure out if sides are parallel.
Like how long they are?
So watch. All right, so I'm going to draw a square onto here. And please forgive my graph. It's a little wonky. All right, so how do we determine if the sides are the same? We count them.
Yes.
All right, so we've got 1, 2, 3. So how big is that side?
3.
They're like little boxes. It's a coordinate plane, so we just call them like 3. Yeah, see, so when you're little and you don't know the coordinate plane, you're like 3, what are those? And then when you're in high school, you're like, oh, that's just 3. All right, now how about this one? We go 1. So how many is that?
3.
Now watch this. Okay, this side has 3, and this side has
3.
So that tells us that we have something that has all 4 sides the same. The way we're going to figure out the 90-degree angles is with perpendicular. But here, we can also figure out parallel. So if I was asking you, like, is this a parallelogram? Are the sides parallel? All you would do is you would find the slopes.
I think I know what a parallelogram is.
You do? You think you know what a parallelogram is? Okay, so a slope for this one, remember, is horizontal.
Yes.
So my slope is 0. This one is also horizontal, so my slope is 0. So I know those 2 sides are parallel. And we draw, I don't know if you guys remember, but they're those little matching arrows.
I know those parallel.
Okay, and then this one is a vertical, so its slope is considered undefined. And therefore, it's parallel to this other one. So even if we don't know for sure this is a square, we could say, because opposite sides are parallel.
Mom?
Yeah, sweets?
I think I heard this.
Then this is definitely a parallelogram. Oh, nice. Okay? So I'm not going to have you do anything as in-depth as that, like in this week's assignment. It's going to be more about counting the sides and looking at the slopes. Because we're really going to be looking at the idea of parallel lines and slopes being the same. So let's do a couple more with pictures, because that's really kind of where we're at.
The circle doesn't have lines.
No, you're right. A circle doesn't have lines. All right. So, say I've got another coordinate plane.
Why are you putting like X's?
Because they call this line, that's this horizontal line, they call that the x-axis, and they call the vertical one the y-axis.
Y-axis, like that? Is that how you pronounce the one that goes down with the Y, Mom?
Y-axis and the x-axis.
X-axis? I can't pronounce that one.
It's so you say x-axis
X-axis?
and y-axis.
So both of them have axis?
Yeah, both of them an axis. An axis is a line. A line that holds, well, we'll talk about that later. Sorry, I'm teaching you and I'm teaching him apparently. All right, so now, when I do this, I did a Desmos activity so you can count it a little bit more easily. All you're doing is counting the rise over the run. And the trick is you just start with any point and count to the next point you find. So, Daniel, which point do you want to start with? Here, you come on up and point to so which point do you want to start with on this line? Okay, you want to start with this one? Okay, now we need to count to this one. So what I'm going to do is I'm actually going to make a right triangle. Because that will show me my rise and my run. All right. Or you can actually even draw it down this direction and that will work as well. All right, so how far do I have to go down or up to get from here to here?
3.
How many is this?
2. I mean 1.
1. And did I go up or did I go down?
Down.
Down. So that's a -1. So my rise is -1. And you can tell because if you put your mathematician to the left and they start walking, they're going downhill. So it's a negative slope. All right. Now, to go from here to here, how many did I go forward?
1.
How many?
0. 2.
2. So this one has a slope of -1/2.
This is kind of easy.
Well, there's a lot more to it, buddy. All right, now pick a point anywhere on this bottom line.
There.
This one? Okay. All right. Now, I'm going to jump up to this next line. So how many did I go this direction?
1.
1. Is that positive? Is it up or down?
Up.
Up. So I went 1. Now, wait a second. You're going, wait a minute. This is a negative and this is a positive. They're not the same. But watch this. Now, I'm going to go this direction. Here, how many did I go?
2.
2. Did I go forward or backwards 2?
Forward.
Did I? To go this direction?
Backwards.
Backwards. Backwards gives me a negative. Now, he doesn't know that as well because he's not used to the coordinate plane, but if you go to the right, you're going positive. If you go to the left, you're going negative. Now, people might say, well, but maybe Miss Siddick, the numbers are the same, but the signs are wrong because this one's a -1 and this one's a -2. Those are actually equivalent. -1/2 is the same as 1/-2 is the same as -1/2. As long as it only has one minus symbol, it doesn't matter where that symbol lives, it's still just negative. So this is a slope of -1/2. This is a slope of -1/2. Therefore, these two lines are parallel. All right? Yep, parallel. Okay, now I'm going to do a separate video for perpendicular so that you can see how perpendicular works and know that the activity is really this week is going to focus on the idea of counting parallel and perpendicular slopes. Okay, so be ready for that.